Okay, good evening, students. So, in the last class, we were discussing about the flood lighting, street lighting, and the factory lighting. That means what? How will be the factory lighting will be done? How will be the what are the different kinds of lamps will be used over there, and how much the illumination should be provided. So that and all we have studied in the last class. In today's class, we will solve some problems related to the illumination engineering, that is designing of the lighting scheme. For example, if you consider any room or in any domestic application, so how many lamps should be installed and what distance they have to be installed, so that we will study in today's class. So first problem will go like this. One is a small assembly shop is there. It is having 16-meter long and 10-meter wide, and 3-meter up to the trusses is to be illuminated to a level of 200 lux. The utilization and the maintenance factors of 0.74 and 0.8 respectively. Calculate the number of lamps required to illuminate the whole area if the lumen output of the lamp selected is 3000 lumens. So this is the problem they have given, and in this problem they have given that the small assembly shop, which is having a dimension 16-meter in length and 10-meter in wide and 3-meter in height. So this is the thing they have given, and the illumination they have given as 200 lux, and the utilization and the maintenance factor they have only given, which is 0.74 and 0.8 respectively. And we need to calculate the number of lamps required to illuminate the whole area, and the lumens output also they have given, which is 3000 lumens. So this is the given data, and from which we need to calculate how many numbers of lamps which are required to illuminate such a small assembly shop. So this is the thing. So how do we go with this? So firstly we need to calculate the working area. So the working area is nothing but what? Sorry. So the working area is nothing but what? Area is nothing but length into width, which is nothing but 16 into 10, which is equals to 160 meters square. And that is next we need to calculate required illumination, which is given in the problem, which is 200 lux. And total lumens required is nothing but what? It is illumination into area. So because we know the formula that illumination is nothing but flux per unit meter square, that is how much flux is falling per meter square is nothing but the total lumens required. So therefore phi is nothing but what? E into A, which is nothing but 200 into 160, which is equals to 32,000 lumens. Next, total lumens to be given out by the lamp. So this is the lumens which is required by the area to get illuminated, but we also need to calculate how much lumen which is given out by the lamp, because whatever the lumens or flux which is given out by the lamp, so only that means all flux will not be falling on the area. Some of the flux may absorb through atmosphere, or something will happen. So therefore the flux, like if we take 100% of flux, the 100% of flux will not reach the working place, because in between them there will be a air medium or any other medium will be there. So therefore absorption will be there. So therefore we also need to calculate the total lumens to be given out by the lamp. So how do we calculate this? So we'll calculate by this formula, which is nothing but total lumens required on working area divided by utilization factor into a maintenance factor. So because utilization factor is needed, because how much factor the area is utilizing the lumens, and maintenance factor how far we how far we maintaining the lamp. So therefore, the total lumens given out by the lamp will be calculated by this formula, which is total lumens required on working area divided by utilization factor into maintenance factor. So therefore, total lumens is nothing but 32,000 divided by utilization factor into maintenance factor, which is zero point 0.8. You will get the answer, which is 54,000 lumens. Next, we need to calculate number of lumens. So to calculate that, so how do we proceed means, which is nothing but total lumens given out by the lamp divided by lumens output of each lamp. If we calculate this, then we can easily calculate how many number of lamps are required. So you can see over here, so how much lumen is calculated over here, and lumen output they have given, which is 3000 lumen. So therefore, this is nothing but 54,000 divided by 3000, which is nothing but 18 is the answer. So the number of lumens is nothing but what? That means what? The flux given out by the lamp and the lumen output of each lamp. Because we are not installing only one lamp in the assembly shop. We are going to install. You can see over here 18 lamps in the required hall. So therefore, what we to calculate the number of lamps, we will go in this way, that is total lumens given out by the lamps divided by lumen output of each lamp. So if we divide this, then you will get the answer, because this is the total flux which is given out by all the lamps, and this is the total flux which is given out by only one lamp. If you divide this, then obviously you will get the answer, which is the number of lamps required. So to calculate this, how do we proceed it? So first, this is the formula, which is nothing but total lumens given out by the lamp and lumen output of each lamp. So lumen output of each lamp they have given in the problem itself. And to calculate the total lumens given out by the lamp, so we will go with this way, that is total lumens required on working area divided by utilization factor into maintenance factor. So if we divide this, then you will get the answer, which is the total lumens given out by the lamp. Next, so to calculate the total lumens on working area, so we have a formula which is nothing but illumination into area. So if we multiply these two things, then we will get the answer, which is nothing but the total lumens required. So like this, we are going to calculate the total lumens. Sorry, the number of lamps required. So second problem is very important, and these kind of problems will be usually asked in your exams. So second problems will go like this. A room of size 15 into 6 meter is to be illuminated by 20 200-watt lamps. So here they have only specified how many number of lamps are required. So a room size of 15 cross 16 meter is to be illuminated by 20 200-watt lamps, and the MSCP of each lamp is 250. Assume depreciation factor as 1.2 and utilization factor as 0.6. Find the average illumination produced on floor. So this we need to calculate. So a room is there which is having a dimension, that is which is having a length 15 meter and which is having a width which is nothing but 6 meter. And how many number of lamps are used over here, which is 20 lamps are used over here, and each lamp is having a wattage of 200 watt. Then MSCP of each lamp is given, which is 250, which is nothing but the illumination, and a depreciation factor and the utilization factor is given, but we need to calculate average illumination produced on the floor. So how do we proceed with this? So area which is given, which is nothing but 15 into 6, which is nothing but the 19 meters square, that is length into width. Next, MSCP they have given, which is 250, and number of lamps is 20, each having a 200 watt of wattage. And depreciation factor they have given, which is 1.2, and utilization factor they have given, which is 0.6. Next, to calculate total lumens given out by the lamp. So total lumens given out by the lamp is nothing but what? So it is nothing but number of lamps into MSCP of lamp into 4 pi. So this is the formula which we have used in the earlier cases also to calculate the total lumen. So that is nothing but what? Which is nothing but number of lamps into MSCP of lamp into 4 pi, or MSCP of lamp. So we had this formula, right, which is nothing but total flux divided by 4 pi into number of flux. So that will give you MSCP. But to calculate flux over here, which is nothing but number of lamps into MSCP of lamp into 4 pi. So number of lamps they have given, which is 20, and MSCP is 250, and 4 pi we know. So therefore you will get the answer, which is 62,832 lumens. Next, we need to calculate lumens reaching on working plane. So how do we calculate this? So to calculate the lumens reaching on only the working plane, so we have this formula, which is nothing but phi into UF by DF. So these formulas are very important. So to remember this, I can list out the formulas for you also. But to calculate this, you have to be very careful. So lumens reaching on working plane, the formula will be different. Lumens given out by the lamp, which is also different. So if the lumens given out by the lamp is got to know, then lumens reaching on working plane will be calculated by this formula, that is phi into UF by DF. But in the earlier problem, you can see over here, that is total lumens given out by lamp is nothing but what? Which is nothing but total lumens divided by UF into MF. So this is the difference. So this thing you have to be thorough while solving this problem. So total flux given out by the lamp is different. Total flux reaching the working plane is different. So total flux given out by the lamp, if the total flux reaching the working plane is known, then you will multiply that you will divide the lumens by utilization factor into maintenance factor. But if the lumens by the lamp is got to know, to calculate the working plane, so we have to do this thing, that is phi into UF divided by DF. That will give you the exact answer. Okay, so this is very important when calculating this. So you have to be very careful. Lumens given out by the lamp is different. So if you know the lumens on the working plane, then you have to divide phi by MF into UF. If um, the lumens given out by the lamp is known, and you need to calculate lumens reaching on the working plane, then you have to go in this way, that is phi into UF divided by DF, or you can say phi into UF into MF. Okay, so MF maintenance factor is usually the reciprocal of depreciation factor, so you go with that way also. So therefore lumens given out by the lamp, if the lumens reaching on working plane is given, then you have to divide lumens reaching on working plane divided by UF into MF. And if you know the total lumens given out by the lamp, and you need to calculate total reaching on the working plane, total flux reaching on working plane, then you have to multiply utilization factor into maintenance factor, or you can divide by depreciation factor. So this is very important. So therefore we have the phi value, and UF is given, DF is given. So therefore the value lumens reaching on working plane is nothing but 31,416 lumens. Next, illumination on working plane. We need to calculate. So now we have calculate lumens which is reaching on working plane, but we need to calculate illumination on working plane also. So how do we go with this? So illumination is nothing but what? Flux by area. So therefore lumens reaching on working plane divided by total area to be illuminated, which is nothing but 31,416 divided by 90, which is nothing but 350 lux. So in this way we can calculate the average illumination on working plane. Next, we have third problem. This problem is very important. That is disposition of lamps. That is how we are going to design the lamps in certain places. So that is very important. So please go through it once or twice again. So third problem will go like this. An illumination on the working plane of 75 lux is required in a room of dimension 72 meter into 15 meter in size. The lamps are required to be hung 4 meter above the workbench. assuming a suitable space to height ratio, a utilization factor of 0.5, a lamp efficiency of 14 lumens per watt, and a candle power depreciation of 20%, estimate the number, rating, and disposition of the lamp. So this is something like estimation problem. So here they have given many data. So first of all, we can calculate the area, which is nothing but length into width, which is nothing but 1080 meters square. And illumination they have given. So illumination will be represented by the letter E, which is nothing but 75 lux. Next, the lamps are required to be hung 4 meters above the workplane. This is nothing but what? It is a mounting height. So therefore, mounting height or H is nothing but what? It is nothing but 4 meters. Next, here we can assume any suitable space to height ratio. So while assuming suitable space to height ratio, it is usually varying from zero point 0.6 to 1.5. Okay, so this is actually the varying range of space to height ratio. So we can usually assume from zero point 0.6 to 1.5. So this is the thing, and a utilization factor of 0.5 is given, that is UF is 0.5, and lamp efficiency they have given, which is eta is nothing but 14 lumens per watt, and candle power depreciation is given, which is they have given in terms of percentage, which is nothing but 20%. So in this problem, we need to calculate how many number of lamps are required and what is the rating of each lamp and how we are going to disposition them. So this is the thing. So we have listed out the data. Then total lumens we can calculate. Phi is nothing but what? Area is known. Illumination is known. So you can see here E is nothing but what? Lumens by area. Then if you want lumens, then you have to cross multiply it. That is nothing but illumination into area, which is nothing but 1080 into 75, which is nothing but 81,000 lumens. Next, we need to calculate, that is utilization factor is given, which is nothing but 0.5, and maintenance factor we can calculate by this way, which is nothing but 1 minus candle power depreciation. So this is the formula if they have given candle power depreciation. So how do we go with this, which is nothing but maintenance factor is nothing but 1 minus candle power depreciation. So which is nothing but 1 minus 0.2, it will give you the value which is nothing but zero point 0.8. In this way, we need to calculate maintenance factor. Next, gross lumens required is to be calculated. So how do we calculate the gross lumens means we calculate in this way, which is nothing but phi is nothing but what? So here in the last problem, in the last step, we have calculated total lumens required, but we have not calculated how many lumens actually falling on the working plane or which is utilized by the working plane. So this is the total lumens which is falling on the working plane. But this is not the actual lumen, because as I told you, there may be a atmosphere which is absorbing, and there may be a working space which also absorbing the part of light. So therefore, gross lumens can be calculated by this way, which is nothing but E into E, that is nothing but total lumens divided by utilization factor into maintenance factor. As I told you, if you want to calculate total lumens on a working plane, um, that is nothing but you have to divide the value by UF into MF. And if you want to calculate for a particular area, then you have to multiply the UF into MF. So that is very important. So therefore, gross lumens required is nothing but total lumens generated divided by UF into MF. So this is nothing but 81,000 divided by 0.5 into 0.8, which is nothing but 2 lakh, 2 lakh 2,500 lumens. Next, total wattage required is to be calculated. So how do we go with this? So we have lumens, and luminous efficiency is given, which is nothing but lumens per watt. Lumens by lumens per watt, lumens get cancelled, you will get the answer, which is nothing but total wattage. So this is nothing but phi divided by lamp efficiency. So this is nothing but what? Phi is known and lamp efficiency they have given in the problem. So therefore, you'll get the answer, which is nothing but 14,464 watt. Next, in the problem only, they have told that you assume suitable space to height ratio. Usually, we will assume its range may vary from zero point 0.6 to 1.5, but usually we will assume the space to height ratio in the range zero point 0.9 to 1.3. Zero point 0.9 unity, in most of the problem, we assume that space to height ratio is unity, or zero point 0.9 or 1 or 1.1, 1.2, 1.3. Only these five values we are going to take. So in this problem, in textbook also they have assumed the space to height ratio as zero point 0.9. You can assume unity also, 1.1 also, 1.2 also, no problem. So you can assume any value between zero point 0.9 to 1.3. So here we have assumed that space to height ratio as zero point 0.9. Next, space to height ratio. So the name itself tells that it is the space divided by height. Which space? It is the horizontal space divided by the mounting height. So this is the space divided by the mounting height. So they have given in the problem. So we can actually calculate the horizontal distance between the lamp. So therefore, so how do we calculate this? Which is nothing but zero point 0.9 is the horizontal space to height ratio we have assumed, and the mounting height is 4 meter. So therefore, horizontal distance between the lamp, or we call it as axial spacing between the lamps. So therefore, axial spacing is nothing but x direction, which is nothing but what? It is nothing but 3.6. If you multiply zero point 0.9 into 4, you'll get the answer, which is nothing but 3.6 meter. So therefore, while designing the problem, you have to take that the distance between each lamp should be 3.6 meter in horizontal direction. Then we have to calculate how many number of lamps you are using in a horizontal direction, because not only one lamp we are using, so many number of lamps we are using in the horizontal direction, and to provide uniform illumination. So therefore, number of lamps in horizontal direction is nothing but total length of room. So we are calculating number of lamps in horizontal direction. So therefore, we need to take length, which is in the horizontal direction itself. So therefore, total length of room divided by horizontal distance of lamp. So total length of room is given, and now itself we have calculated horizontal distance between the lamp. So therefore, 72 by 3.6, which is nothing but the 20 lamp. That means what? So you have to fix 20 lamps in horizontal direction. If you take 72-meter distance, in 72-meter distance, you are going to install, or you are going to fix 20 lamps with the horizontal spacing as 3.6 meter. Okay, so in this way we have calculated number of lamps in horizontal direction, but we also have to calculate number of lamps in width direction, or nothing but y direction. So how do we go with this? So first of all, we have to calculate number of rows or lamps in vertical direction. If you calculate number of rows, it is also similar to the number of lamps in vertical direction. So to calculate that, we will use this formula, which is nothing but total width of room divided by horizontal distance between the lamps. So total width of room divided by horizontal distance between the lamps will give you how many number of rows are there, or how many number of lamps are there in vertical direction. So width of room, you know that. The horizontal distance between the lamps, you know. So if you divide these two things, then you'll get the answer 15 by 3.6, which is, you will get the answer 4.166, which is nearly equals to 4 rows, or we call it as 4 lamps in vertical direction. So now we have got to know that there are 20 lamps, that is in the dimension of 72 meter and in 15 meter. There are 20 lamps in 72-meter distance, and there are 4 lamps in width direction. So that means what? There are 20 columns and 4 rows. So 4 into 20 means what? There are 80 lamps are there. So now we also have to calculate the vertical distance, or we call it as transfer distance or transfer spacing. So the transfer spacing is nothing but what? It is the vertical distance between the lamp. Okay, so this we also have to calculate. So how do we go with this? This is nothing but total width of room divided by number of rows or number of lamps. So 15 by 4, you will get the answer, which is nothing but 3.75 meter, which is nothing but the transfer spacing. or we can calculate in this method, or we can go with another method also. Let us assume, so this is something like horizontal space to height ratio, and we can also assume vertical space to height ratio, which is nothing but 0.9375. So vertical space to height ratio is nothing but vertical distance between the lamps divided by mounting height. So therefore vertical distance between the lamps can be calculated 0.9375 into 4, you will get the answer 3.75 meter. Next, number of lamps can be calculated by this formula, total width divided by vertical distance, which is nothing but 15 by 3.7. You will get the answer 4 lamps. Next, disposition of lamps. So disposition of lamps is nothing but this. So in the exam you have to draw this diagram. Okay, so this diagram is very important, and this marking is also very important while you are drawing this. Okay, so you can see here. So this room is having length of 72 meter and is having a width of 15 meter. So in the problem, we calculated that there are 20 lamps in 72-meter distance or in the horizontal direction. So you can see here in the horizontal direction, there are 20 lamps. If you calculate this, there are 20 lamps in the horizontal direction, and there are 4 lamps in vertical direction. You can see here there are 4 lamps in vertical direction. Or we can say there are 4 rows and 20 columns are there. And we have calculated the horizontal spacing, which is nothing but 3.6 meter, and vertical spacing we have calculated, which is nothing but 3.75 meter. So these things we have calculated. So this is nothing but the disposition of lamp. Next, we also have to calculate this distance. See, whatever the distance we have calculated, horizontal distance, which is nothing but distance between the lamps. You can see here this 3.6 meter is nothing but distance between these two lamps. But this distance we got to know. But we also have to calculate the distance between lamp and the wall. You can see over here. So this is the wall. So you have also have to calculate the distance between the wall and the lamp. So how do we calculate this? So we will calculate in this way. You can see here there are 3.6 meters. So how many distance are there between the lamps? There are 19 are there. You can see here there are 19 3.6 meters are there. That is nothing but um, the 3.6 meter is nothing but distance between the two lamps, which is 19 times it is that. If you add this, then you will get the answer, or if you multiply with 19, because there are 19 3.6 meters are there. 19 into 3.6, you will get the answer 68.4 meter. But the actual length is how much? It is nothing but 72 meter. But we have remained with how much meter? It is 3.6 meter. The lamps are covering only 68.54 meter, and the left meter is how much, or the left distance is how much? It is 3.6 meter again. So there is a 3.6 meter is lagging. So how do we calculate this? The distance of lamp from wall on either side of horizontal direction. You can see here this is the wall. Then the distance of lamp from wall on either side. This is one distance and this is one distance. So therefore, combining these two, you'll get 3.6 meter divided by 2 means you'll get 1.8 meter. So therefore, 1.8 meter is nothing but it is the distance of lamp from the wall. Understood? So this is nothing but this distance. Next, we have calculated in the horizontal direction. In the same way, we need to calculate in vertical direction. So how many distances are there? 3.75 meter. There are 3.75 meters distance are there, and it is covering only 11.25 meter. But the actual length width is 15 meters. So 15 minus 11.25 is 3.75 meter. So therefore, distance of lamp from ceiling, this distance, vertical distance on either side of vertical direction is nothing but 3.75 by 2, which is nothing but 1.875 meters. So therefore, this is the distance of lamp from ceiling and the lamp. Okay, so this is the distance. So like this, we need to calculate this distance also. So next, how many number of lamps are there? So there are 20 rows into 4 columns is nothing but 80 lamps, or 20 lamps in horizontal direction and 4 lamps in vertical direction, which is nothing but 80 lamps. So how do we calculate wattage of each lamp? So can be calculated by this way. So total wattage is already calculated. Divided by number of lamp will give you the wattage of each lamp. So therefore 14,464 divided by 80, it will give you the answer 180.8. But 180 watt bulb is not available. If you take a nearby wattage, which is nothing but 200 watt. So instead, usually 180 watt lamp is not available, so you can use 200 watt. Like this, we need to calculate. So next, also this is also similar problem to that. So estimate number and wattage of lamps which would be required to illuminate a working space of 60 cross 15 meter by means of lamps mounted 5 meter above the working plane. The average illumination required is about 100 lux. Then the coefficient of utilization is 0.4. Luminous efficiency is 60 lumens per watt. Assume a space to height ratio of unity and a candle power depreciation of 20%. So here also we need to estimate that is how many lamps required and what is the wattage of each lamp, and we also have to draw that is position diagram, and this is the thing we need to calculate. So for that they have given the average illumination, UF they have given, efficiency they have given, space to height ratio they have only given, you assume the value as unity, and the candle power depreciation is 20%. So we will proceed with the same way. First of all, you list out all the data. Then gross lumens required is nothing but what? Which is nothing but A into E, A into E divided by UF into MF. So therefore, A into E divided by coefficient of utilization into MF, which is nothing but 900 into 1000 divided by zero point 0.4 into zero point 0.8, which is nothing but 2,81,250 lumens. Next, total wattage required we need to calculate. So total wattage required is nothing but what? Which is nothing but flux by lamp efficiency. So 2,81,250 divided by 16, we'll get the answer 17,578 watt. Next, given space to height ratio as 1. That is, they have only given the problem. So therefore, space to height ratio is nothing but horizontal space distance between the lamps divided by mounting height. So the mounting height is also given, which is nothing but 5 meter. So therefore, 1 by 5, it is nothing but 5 meter, or axial spacing is nothing but 5 meter. Next, number of lamps in horizontal direction. How do we calculate this? So this is nothing but total length of room divided by the horizontal distance. So it will give you the answer 60 by 2, which is nothing but 12 lamps. So there are 12 lamps in horizontal direction. Next, in the same way, we can calculate the vertical direction. That is room direction. So transverse spacing can be calculated by this way, which is nothing but the total width of total width of the room divided by number of lamps or number of rows. So 15 by 3 is nothing but 5 meter. So we will draw a disposition diagram. You can see here. So this is the 5 meter is nothing but the horizontal distance, and the distance of so the distance between each lamp in horizontal direction is 5 meter. Again, the distance of lamp in vertical direction is also 5 meter. That is, axial spacing is 5 meter and the transverse spacing is also 5 meter. Next, as I told you, there are, you can see here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 times the 3.6 meter, 5 meter distance are there. So therefore 5 into 11. So this will cover only 55 meter. And we have left out with 5 meters. So this 5 meter is nothing but what? It is 5 meter. So therefore this is divided by 2 will give you the answer. This is actually the distance of lamp from the wall. So this distance is nothing but what? It is nothing but 2.5 meters. So to calculate this, we have to calculate it in this way. Again, in the distance of lamp from ceiling on either side of lamp is actually, again you can see here 5 into 5, 2 times, which is nothing but 10 meters. So we have left out with again 5 meters. So 5 by 2 is nothing but 2.5 meters. So this is the distance of lamp from ceiling and the lamp. Next, total number of lamps means rows into columns. So there are 3 rows into 12 columns. So that is nothing but 36 lamps. Wattage of each lamp can be calculated, total wattage by number of lamp. So therefore, 88.3 you'll get, but which is nearer to 500 watt. So next we have fifth problem. So this is also similar to that. A hall 30 meter by 15 meter with a ceiling height of 5 meter. So please note that here the ceiling height is given. That is the distance of the space between the floor and the ceiling. It is not the mounting height. So be careful that ceiling height is different, mounting height is different. So if they give that mounted at a distance means it is the mounting height. But here in this problem they have given ceiling height. And general illumination 120 lakhs, coefficient of utilization, depreciation factor they have given, and we need to determine the number of fluorescent tubes required and the spacing, mounting height, and the total wattage. So the total luminous efficiency is given, and for 80 watt bulb, that is the wattage of each bulb, they have only given this in this problem. Okay, so wattage of each lamp is also given. So first list out the data, UF into MF into DF divided by U. You have to write in denominator, so therefore here you have to write in numerator. Total wattage required is nothing but lumens by how many lamps is required. So the number of lamps can be calculated in this problem. But what it is nothing but total wattage of lamp divided by wattage of each lamp. So therefore, 3780 divided by 80, which is nothing but 47.25, which is nearly equal to 48 tubes. So there are 48 tubes are there. So therefore, there are 48 tubes are there. So for actually here we have considered that we have round actually we can calculate for 48 tubes also, no matter, because it is a even number. Usually we will take even number of lamps, but here they have rounded off to 50 tubes. So let us take total lamp as 50, because if you increase the lamp then you will get better illumination, because it is a hall also. So therefore